Okay, so we'll do a couple of these. I think sample number 3 is a vertical one, so we'll get to that a little bit later. There are a couple of formulas that I need to sort of give you that you should have encountered somewhere along the way, but you may have forgotten or what have you, right? To do with frequency and stuff like that. So here we have an object of mass 1.5 kilograms, so it's pretty heavy. It's tied to the end of a string that's 0.5 meters long, and it's swung in a horizontal circle with UCM such that it makes 5 revolutions in 4 seconds. Find the frequency, the period, the speed, centripetal acceleration 2 ways, and the tension in the string. Okay, so a lot to cover here. Okay, so first of all, frequency. What does frequency mean? And we haven't really discussed this, so this is our chance. Frequency means, like, how often do we meet? Every day, every 24 hours. That is the frequency, right? So it's how many times per something. So if it's 5 revolutions per second, in this case here, it refers to the revolutions per second. Okay, so there's 5 revolutions in 4 seconds. So what is the frequency? It's 5 divided by 4, or 1.25. 1.25 revolutions per second. Now, there's a special word, special unit for revolutions or cycles per second. Anyone know what it is? I'll give you the symbol. It's Hz. Hertz. No, it's not too bad. It's just a little pain. Okay? You've probably heard about megahertz and gigahertz and stuff like that, right? So that's what they're talking about there. Okay? Hertz rent-a-car. I'm not really sure what that has to do with frequency. But anyway, so 1.25 hertz. That is the frequency. Now, period, there's a relationship between period and frequency, and it's like this. Period is equal to 1 over the frequency. They are inverses of each other. So it's 1 over 1.25, which is equivalent to 4 over 5, by the way. It's just the inverse, flip-flop. So 0.8 seconds. Period is measured in seconds. The only reason I asked for those two is to show you this relationship so that you can use it later. Okay? So sometimes you're going to see this data given to you in frequency. Sometimes you're going to give it to you in period. You just have to be able to convert from one to the other, that's all. And all you do is just invert them. Okay? Okay. Speed. Again, let's go back to our basic V equals D over T. And this is one of the few times that I actually like to go formula sideways. I don't know why. I just like it this way. Displacement is circumference, 2 pi r over big T, 2 pi radius of the string of all those numbers, which is the one that is the radius, the 0.5. The string is 0.5 meters long, divided by big T, 0.8, and you get 3.93 meters per second is the speed of this object. At this point now, we need to find the centripetal acceleration. I've asked it for 2 different ways simply because I want to show you how both formulas work. Obviously, I might ask you 2 different ways on a test, but probably not, right? But I want to show you both ways. So, given the new formulas that you got today, A equals V squared over R. Technically, this is centripetal acceleration. If you want to put a little c there, you can. So it's simply 3.93 squared all over R, 0.5. The centripetal acceleration is a whopping 30.9 meters per second squared. A significant acceleration. Will the other formula that we got earlier give us the same result? It should. It better. It's a little more tedious. It's got a little bit more to it. 4 pi squared. The radius is 0.5. T squared is 0.8 squared. Here's where calculator skills are very important. You need to be able to know what order to punch the buttons in to get this, right? It's going to be 4 times pi squared times 0.5 divided by 0.8 squared, and then you got to go equals, because if you don't go equals, you're just going to get 0.8 squared. Do you get the same number? Well, it's pretty darn close. I get 30.8. Is it close enough that there's some kind of rounding error somewhere? It could come from, although you should, I know that some teachers are telling you not to use the pi button on your calculator because not everyone has it. I would prefer that you use it because it's a little more accurate, right? So that's one number I use the pi button. So again, you show your work. If you get 30.7, I'm not going to squabble over 0.1 meters per second squared. Okay, so they're reasonably close. I should caution you because I've seen this plenty. This formula right here is a little dangerous. And the reason for that is because area of a circle, pi r squared. Centrifugal acceleration, 4 pi r squared. People think it should be the same, pi r squared. It's not. It's pi squared r. More than once I've seen that written on a test, 4 pi r squared. The pi is squared, not the r. So be cautious. E. E is the tension in the string. What is tension? Yeah, it's equal to the centripetal force. Lots of different ways you could do this. The simplest, Fc is equal to MAC, the mass 1.5. Pick one of those accelerations, 30.9, and multiply. 46.2 newtons. You could also have said Fc is equal to mv squared over r, or you could have said Fc is equal to m4 pi squared r all over t squared. Jason.
You just take the mass and times about 30.9.
That's what I did right here, right? In essence, what you're doing in these two formulas really is doing what? Is doing this step and then this one all in one step. That's all you're doing, right? Remember those good old days when you might have seen, hang on here. Remember the magic triangles? Did anyone ever get taught the magic triangles? No? Anyone? No one has ever seen those? Oh, good. You remember those? Yeah? The magic triangles? They were great, right? I challenge you to come up with a magic triangle for that baby. That's why I don't like the magic triangles. You really want to see them?
Yeah.
Okay. Have I got time? Yeah. Ooh. Put a V there, and a D there, and a T there. Am I right, Joey?
Yeah.
Okay. So to find velocity, you cover it up. Make a little square here. Let's make it orange. If you want to find velocity, you cover it up. Velocity is equal to distance over time. If you want to find displacement, it's velocity multiplied by time. And if you want to find time, well, it's displacement over velocity. It's a nice little handy trick, right? But you really need to be able to rearrange that, right? At this stage of the game. Because you can't come up with a magic triangle for something like that. Yes, exactly. And that's almost the words that I use. I usually say rhombus because it's funnier. But pentagram's good, I'll remember that. Yeah. It's a nice little trick for easy formulas. Okay. Is that hard? Like really, when you stop and you look back, it's not too bad, right? It's new, I get that, right? But it's not too bad. Do you want to try that? You know what? I don't have time for you trying it on your own. Let's just do it. Because I don't. There's only 3 steps. The trick is the logic here. A string can withstand up to 7.5 kilograms hung vertically on it, and then it breaks. If you fish, what does 20-pound test mean? Anybody fish in here? I don't, but I know what 20-pound test means. Nobody? it means that it should be able to hold a 20-pound fish, right? It's been tested as rated for that, right? So this string can withstand up to 7.5 kilograms, hung vertically on. Then it breaks. A piece of string 4 meters long is used to whirl a 2-kilogram mass in a horizontal circle faster and faster and faster until it breaks. That sounds like fun. Wear eye protection. Find the braking force of the string. Find the maximum speed reached before braking and the period of motion at brake time. And I don't mean in the next 8 minutes. Okay, what is the braking force? This 7.5 kilograms is what will cause the string to break when the force of gravity is equal to 7.5 times 9.8, or 73.5 newtons. So the fishing line is tested over and over again, and the average is determined that it breaks at around 73.5 newtons. That's what it's rated for. Okay, now in part B, the 7.5 kilogram mass is now removed from the string because it says a piece of string 4 meters long is used to whirl a 2-kilogram mass in a horizontal circle. The mass is now 2. See how the mass has changed? Little trick there. I want to know the maximum speed reached before braking. Well, it breaks when the centripetal force is equal to 73.5, right? Centripetal force is equal to mv squared over r. So 73.5. Again, which mass do I use? 2. We're solving for speed. And the radius is, it's a giant string. It's 4 meters long. Good luck whirling that around your head. Stand back too, by the way. Okay, solve this little baby here. So it's going to be 73.5 times 4 divided by 2 is equal to v squared. V is the square root of that big mess. And you get 12.1 meters per second. The string will break when the object reaches 12.1 meters per second. That's pretty fast. That's like about 40 kilometers an hour. Maybe more, maybe 50. Okay, last one, and then we're done. Period of motion at brake time. How long does it take to go around that circle at 12.1 meters per second? Because that's when it breaks. T equals 2 pi r over v. 2 pi, radius is 4, velocity 12.1. I'll squeeze it on this page. 2.08. Bunch of useless information. Bunch of junk, right? Dan?
Oh, yeah.
Bunch of junk. Do the designers of salad spinners need to worry about this? No. I'm only going to do those two. I think, in fact, I'm not, is it even in there? Is sample number 3 in there? Yeah, it is. Okay. Quick look at sample number 3 says that sample number 3 talks about what kind of circle? A vertical circle. Vertical circle. Now, just a very quick foreshadowing here. Instead of horizontally, right, like this, where gravity is doing this everywhere, and we basically kind of ignore it. Now we're talking vertical, right? Gravity is, oh. Do you get the feeling that this is going to cause some problems? Yes. And if you take that, I've seen that. Have you seen that? Right there by the police station, that the house has the big trampoline turned sideways with the dream catcher on it. Yeah. Kind of cool. I always want to run at it and see if I can like bounce off it, you know. Yeah. So we'll deal with that later. Don't do sample 3. You have a problem pack here. Do not do any questions that say vertical circle. It may say that the object is hung vertically, like number 8, okay? But look for the words vertical circle. Don't do those ones yet. Okay? I will save those for a special day. Okay? So tomorrow, I don't have a whole lot of time here. Tomorrow, complete the lab as best you can. If you want equipment, I've left it all right here. Okay? The safety glasses are they back there, Dan? Yes, they are. The safety glasses are back there. Right? And I think the new apparatuses are back there on the shelf as well. I don't know who the sub is. Wear the safety glasses. Encourage the sub to wear safety glasses. I'll leave a note saying it's okay. They know what they're doing. They're fine. Okay? You can finish the lab. If you have some free time after that, you can work on problems. I will reevaluate on Monday, I guess. I won't see you till Monday, right? Okay, so on Monday, I'll make a decision whether or not I'll probably talk about vertical circles on Monday, depending on how far we've got. Okay? Bye.